Um, Kia ora tātou katoa, no mihi nui ki te kōrero. Good morning, everyone. Welcome to today's talk, Climate Action Through Design, on the last day of the Auckland Climate Festival 2021. We're recording this event today, so it'll be available for rewatching or sharing later. And our two presenters today will present for about 35 minutes, leaving plenty of time for questions at the end. So we'd really like you to drop any questions you have for the team into the Q&A function, and I'll keep an eye on those and we can put them to the presenters at the end of the presentation. So thanks very much for joining, and I'll introduce our speakers. On to that next slide, please, Fee. There we go. Morning, everyone. I'm Richard Archibald. I'm a principal in Mahoney, Auckland studio, and I'll be facilitating the talk today. The two speakers today are Joe Quad. Now, Joe's a senior sustainability engineer at Cosgroves. He grew up living in Germany, Singapore, California, and Montreal, and has been working in Vancouver for 7 years before moving to work here in Aotearoa. And Joe's a registered passive house designer, and he'll be showing some of his project work today. Fiona Short is Warren and Mahoney's group lead of sustainability and an associate principal in our Christchurch studio. Fiona's been with Warren and Mahoney for 10 years, works on a huge range of projects and advocates really strongly for improved sustainability outcomes, both on her own projects and across our entire practice. So we're really pleased to be here today to talk on this last day of the festival and share some thinking with you on the topic of climate change through design. It's very timely with the United Nations Climate Conference kicking off in Glasgow on Sunday. One of the key goals that conference talks about, which is really worth checking out on the website and having a read, is mitigation. And they state that the world needs to halve its emissions over the next decade and reach net zero carbon emissions by the middle of the century if we're to limit global temperature rises to 1.5 degrees. So today, our two presenters, you'll hear from them talking about their vision for a net zero Tamaki Makaurau Auckland and what we as designers can do to achieve it. So a few kind of thoughts from us and from Fiona and Joe about what the future for Auckland might be, this net zero future. Personally, and like many others, I did know in OE, I lived in Japan and the UK and lived there at kind of really high density with really well supported public transport. And when I returned to Auckland in 2008, I really wanted to bring some of those experiences to what Auckland's future could be. I remember realising once I got a car again, what a huge mental weight driving actually was. And it wasn't just about environmental issues in that sense. And I've been really encouraged by the change I've seen over the time I've been practicing back in Auckland as more ambitious moves have gone from early adopters to fast followers. So really my, what I'd like to see Auckland's net zero endpoint be is a city that's diverse, really dense, embraces density in order to arrest its sprawl and preserve its natural amenity. Over to you, Joe.
Kia ora. Thank you, Art, for the introduction. And I'm excited to be here to participate in this discussion about the future of Auckland's built environment today. So my vision for Auckland has two parts. First, I would like to see Auckland take more of a leadership role in pushing New Zealand towards a low carbon future. In terms of the building industry, I see it as in the form of a more progressive local building code. This could involve more stringent requirements, but also incentives for going above and beyond. This kind of system exists in other cities around the world, and Auckland can do the same to set an example for the rest of the country to follow. Second part of my vision is to stop making excuses when it comes to climate action. Minister of Climate Change, James Shaw, said something in the opening event of this climate festival that really resonated with me. He said, we like to say that since we are such a small country and contribute less than 1% to global emissions, what we do here doesn't really matter. But there are 90 other countries in the world that individually each contribute less than 1%, but altogether they make up more than 30% of global emissions. So if they all say that they're too small to make a difference, nothing happens to that entire 30%. Many small changes do add up to a significant impact. The same goes for buildings. If we keep saying that buildings make up an insignificant proportion of our emissions, where are we going to start? Change is within our control as an industry. We know how to do it, so let's start doing things better today.
Nice. So kia ora koutou. My vision for Auckland is for it to be the most livable low carbon city in the Pacific Rim. Kia ora to Archer's cat there. A built environment that is unique to the Auckland climate and culture and that inspires the world. So I grew up in rural Auckland and have lived in the central city for many years of my adult life. And something that I love about Auckland and actually miss is the temperate climate, but also the diverse and vibrant culture and that ambition to really punch above its weight. Recently, I was asked, what is the role of the architect in the 2020s and how is it different from the early 2000s or the 1960s? And thinking about this question and my own experience really clarified my vision for Auckland in a carbon neutral future. I think the biggest challenges or changes to the built environment over the recent years have been driven by advancements in science, technology, and cultural awareness. And this has meant that the role of the architect is now less about providing the answers, but more about driving a process that champions working in new ways with others to design built environments that are informed by science and represent communities in a way that is more meaningful. And I believe this way of working has the potential to lead to a new generation of regional appropriate architecture and deliver on much more than just our carbon targets. My vision for Auckland is for the city to be celebrated globally for approaching climate and the biodiversity crisis with technology and cultural values hand in hand. There's a huge discussion to be had about the relationship of climate and culture, and I want to acknowledge that. But today, really excited to be talking about the part of that vision which is informed by science and technology and discuss actions we can all take to design a carbon neutral future together. So the first part of this discussion, we just want to clarify what we mean when we're talking about net zero carbon or carbon neutrality. Currently, there is an ISO standard being written to define this, which I think is due to be released next year. In terms of today, this is the kind of the calculation we're talking about in terms of carbon neutrality. And we're going to be focusing on operational carbon as well as upfront carbon. So where do we start? What actions can we take to move together towards net zero? Joe.
All right. Okay, so I believe that kind of the key to success and an underlying principle to everything that we do is an integrated design process. The graph shown here may look familiar to some of you. It shows the potential for impact in relation to time. The earlier you change something, the easier it is. In the building industry, this has been widely used to demonstrate the benefits of 3D modeling on the workflow. By modeling in 3D, we have been able to shift a lot of the effort from construction to the design phase. It has allowed us to recognize and resolve many issues in a model rather than on site, saving time and money. But I would argue that there are still a lot of improvements to be made in terms of integration. Our process is still too linear. It typically starts with someone who has a need for a building, hiring an architect. They then work together on a concept that meets all of their needs. During this stage, many building aspects such as size, orientation, and materials get locked in. In some cases, the building then goes through consent, marketing, and even the sale of individual units. So by then, we have moved pretty far along the impact curve before the rest of the design team even gets involved. All these high-level decisions get locked in before the so-called experts get to have any input. This imposes extra constraints the design has to accommodate and often leads to compromised solutions. By involving more design team members early in the process, their input can be more holistically incorporated before it is too late to make any big changes. This is especially true when it comes to sustainability. trying to make an existing design more sustainable will never be as effective as starting off with one in the beginning. Reducing building emissions starts with optimizing our designs. The earlier we think about that, the easier, cheaper, and more efficient it is. So we must incorporate sustainable design strategies right from the beginning, rather than adding them on as an afterthought.
And I completely support that position as an architect. I think working in an integrated way with consultants involved in concept design is the only way to deliver those aspirational sustainable outcomes we will want. In the same way, we need to engage with stakeholders and mana whenua to get the appropriate cultural outcomes. The building performance needs to be co-designed from the outset together as well. And we won't get there with a design process that hands over the design to be engineered when it is already designed. We need to shift the way that many design teams are procured to enable this kind of process earlier and to deliver those outcomes that we want. Which brings us to the next action that we're going to talk about, which is articulating a clear mission or outcome at the outset. So sustainability is a vast topic and it can be hard to know where to start. We need a guiding star for assessing design decisions later. Ask, what are the drivers for sustainability and why? What does success look like? Being able to articulate a clear idea of what environmental, social, or economic outcomes we are aiming to achieve enables the design team to prioritize effort and financial budget into achieving what is of most value to the project and counter that gravity that is really BAU or business as usual. We often get told about how sustainable a project is through a list of sustainable features, and this approach makes it more difficult to get buy-in and is notoriously dangerous because it leaves kind of features open to value engineering. I want to see us talking more about the cake, i.e. the valuable, sustainable, or regenerative outcomes that we will deliver, and then discuss the ingredients we'll use to do that. So having a clear mission is one thing, but a goal also needs measures of success. And this is why your next project needs a carbon brief with measurable targets for operational and embodied carbon. But carbon neutral design is a marathon and not a sprint. And we need to consistently aim for progress to get there, not perfection. So when we have a mission for climate regenerative projects and with a carbon brief, what actions can we take to achieve lower operational carbon? Joe.
Thank you. Okay, I mentioned earlier that we need to stop making excuses. Another one that we really like to make here in New Zealand, as was the case in Canada where I lived previously, is that our electricity is clean because we're using so much hydro and geothermal. So there's no need to change anything. Unfortunately, it's not as clean as we think it is. For example, in the first 3 months of 2021, we used more coal to generate electricity than in all of 2016 and 2017 combined. For various reasons, our cleaner sources of supply have been unable to keep up. Even with all that burning of coal, our demand exceeded supply earlier this year, causing blackouts and leaving people without heat during the coldest nights of the year. This problem is already here, and it's only going to get worse. We do absolutely need to reduce our dependence on fossil fuels to slow down climate change, and part of that solution is electrification, including things like converting more cars to EVs. But that means all those cars will need to be powered by the grid that is already struggling. Projections show that by 2050, our electricity demand will increase by 2/3. Where is all this power coming from? If we keep burning coal to produce it, we've just shifted from one fossil fuel to another. Yes, adding renewable sources like solar will help with some of this, but the only way to avoid an energy crisis is to reduce demand. Buildings use a significant proportion of our electricity, so they have to be part of that solution. Luckily, we already know how to design more efficiently. So this slide here shows some of the passive house principles. So first thing is when it comes to heating our homes, we like to think of heat pumps as being the solution, and they are one of the more efficient ways to do so. But just like those clean hydro dams, they're the supply part of the equation. They don't actually have any impact on the heating demand of a building. The only way to decrease that is through passive solutions. And this is the aim of the Passive House Standard. Basically, by properly insulating and making a building airtight, the heating and cooling demand can be significantly decreased. The key is to reduce the reliance on mechanical solutions. First thing I often hear people say about Passive House that is overkill for a mild climate like we have here. But it's not a prescriptive standard. It provides demand targets, but it does not tell you how you have to meet them. Therefore, a building here needs much less insulation than in harsher climates to reach the same level of performance. So it's actually way easier to achieve. One of the added benefits of prioritizing the passive side of design is resilience. If the power goes out on the coldest night of the year, it doesn't matter how efficient your heat pump it is. It's still not going to keep you warm. Well-insulated building, on the other hand, will. Next slide, please. So this is an example that I had the pleasure of working on before I left Canada. And is a community center, about 6,000 square meter, includes a gym, library, daycare, and theater. Unfortunately, I left Canada before it was completed, so I never got to see the finished product, but it is now the largest Passive House certified project in Canada. And using an integrated design process was a big part of the key to success for this project. And that's what this graph here on the right is showing. So the different dots represent design iterations that were evaluated by the team. The blue line is the cooling demand and the red line is the heating demand. And that orange band across the bottom is the Passive House target of 15 kilowatt hours per square meter per year. The first few options that were looked at are actually different levels of insulation. You think of Canada as being very cold, but cooling was actually more challenging than heating, as is the case in many Passive House buildings. This is due to the heat generated by people, lights, and equipment inside the building. So the options from left to right actually represent a reduction in insulation, allowing more heat to escape, which resulted in a lower cooling demand without significantly affecting the heating demand. The last big drop in cooling requirement shown here is the result of adding natural ventilation to the model. By opening strategically placed windows when the conditions are well suited, the reliance on mechanical cooling is drastically reduced. Another misconception about Passive House is that you're not allowed to open windows. As you can see from the graph, that's not true at all, and it's actually critical to the design. Allowing outside air to enter is a good thing, as long as you can control when and how much air comes in. So it was not one solution that allowed us to meet these targets. There was different team members working together to come up with a combination of solutions. Over the first year of operation, the building has already proven itself. Western Canada experienced a massive heat wave this June, which directly contributed to the death of more than 500 people. Many buildings overheated because they were designed for normal summer conditions around 30 degrees, as was this building. But even when the temperatures outside got as high as 42 degrees, conditions inside this building stayed comfortable. In fact, the building was used as an emergency relief shelter for vulnerable people that did not have air conditioning in their homes, so they could escape the heat. So is Passive House the answer to all of our problems? When it comes to reducing operational energy, it is seen as the gold standard, but that doesn't make it a holistic approach to sustainability. It does not consider what the building is made of, how much waste is generated during construction, or where the materials came from. So it's just one piece of the puzzle. Fiona is going to talk about some of the other pieces.
Thanks, Joe. What I really like about your example is that it uses Passive House and climate modelling to achieve Passive House levels of energy efficiency And I think there's a perception that passive house approach leads to particular outcomes, which may or may not be appropriate for certain places. But I think what this demonstrates is that it leads to climate appropriate design, and that is low carbon, and that those ideas are actually synonymous. Got a question for you. What might be different or the same about the project or the design approach if it were commissioned in Auckland tomorrow?
Yeah, it's a good question. I don't really think there is much of a difference. The process would be exactly the same. One of the keys to success for us was that we had a client that was very ambitious and very committed to achieving his targets. So he's the one that had the vision. And of course, there were hurdles that came up along the way, and other people may have given up or taken shortcuts, but due to that commitment, we were able to stick to those goals and achieve them. So the process would be exactly the same here. As I mentioned, because it's prescriptive standard, potentially the outcome of the building could be different. That might require less insulation because we do have different climate here. So
I'd be really interested to see the differences in the outcome.
Yeah.
So Joe mentioned the holistic nature that we also need to consider. And so now we're going to talk about what actions we can take to achieve low embodied carbon. So the first principle that I want to talk about, or action, is designing with less, which is about increasing material efficiency by designing with less material per area. And there's 4 key strategies that I think are really useful to keep in mind. And the first is really about the basics of less, and that is, do we need it? Does it deliver value? Does it align with that initial purpose of this project? And if it doesn't, can we get rid of it? An example that I like to think about is a Tesla might be the most efficient car, but a bicycle may actually deliver the purpose to get you from A to B. So it's kind of about rethinking what you actually need for this project to deliver on what is really valuable to the client. The second point is dematerialization, which is about the removal of materials that are not necessary also to deliver on that project mission, but is more about selecting materials that have many benefits to a project and that require less complicated build-ups. So things like exposing ceilings and exposing structure, but do be aware that these do not necessarily mean less design work or lower cost. The fourth point is around keeping it lean and keeping it green. And this is really about having that discussion largely with the structural engineer about ways that you can actually reduce the amount of material used to perform the same structural roles in the building. And the third is reuse. I think this is an opportunity to kind of think creatively, thinking about potential use of aggregate from demolition or waste products from the area, from the campus, from anywhere that seems relevant to that client. But also thinking about not just reuse at the start of the building construction, but also through its lifetime. So designing things that can be reused, disassembled, and reconstructed in different ways is a way to reduce that whole of life embodied carbon. Action 6 is around designing lighter. So this is about decreasing that carbon intensity by designing with less carbon per unit of material. And I think this is probably the strategy that gets a lot of airtime at the moment. And the number one strategy people talk about is timber first. And there's 2 kind of driving reasons behind that idea of timber first. And timber is the one of the best materials when we're looking at a carbon intensity pyramid of different materials that you could use. And the 2 reasons behind that is, firstly, carbon sequestration, which is not only timber. So any plant-based material delivers on those same objectives and potentially better. But the second part of that is about being an intrinsically natural material and requiring less manufacturing processes and therefore less energy and embodied carbon to produce those materials. So keeping those fundamental kind of ideas behind a timber first approach, there are lots of ways to adopt that same approach without necessarily going full timber. The second idea is about looking for the best in class. So we know that different materials offer different properties, and there will be needs for steel and concrete, but it's about doing that in a way that is the best that we can do. So looking for the best concrete mixes that reduce the embodied carbon content is a really good way to reduce the overall carbon, even when we can't have timber everywhere. EPDs, so environmental product declarations. Look for them, ask suppliers for them, understand them. Once we begin to understand these documents in more detail, we can really start to select the most appropriate products. And we need to see a lot more of these in New Zealand at the moment. And the last is recycled content. So selecting products that have a high recycled content, but are also highly recyclable, and making sure that we have a whole of life and circular economy kind of mindset when looking at material selection. And the example that I'm going to share with you today is a project that I worked on based in Dunedin for Otago Polytech, and it was a trades training centre. And I'm going to talk about some of the strategies that this project adopted. So our brief was to design a facility that supported the Polytech's ethos about regenerative design, and that would demonstrate this thinking in the building, so that it could educate those who used it, who would go on to work in the construction industry. The building is actually part of their 4th Street campus, which was the 11th project globally to register as a living community. And so it has a 50-year regenerative master plan in place. And this project was key to them starting on that journey. And this project used a sustainability framework based on the 22 imperatives of the Living Building Challenge. Part of that is low carbon. So our approaches to low carbon included a timber first approach, where we looked at structure, floors, internal walls, stairs, handrails, and also making sure that those came from really sustainable sources. Sources that actually replace trees when they're harvested, to make sure that that carbon sequestration continues. For this particular building, we ended up with a hybrid structure, concrete on the basement levels with LVL and CLT timber structure above. Our second strategy that we took to lower the embodied carbon was dematerialization. And you'll see a reduction in the level of finishes in this building, which also had the co-benefit of exposing those systems so that the students could understand them in more detail, and how the kind of building works as a machine. The third strategy was around reuse. So we looked at what waste materials were available. The metal grates you can see on the balustrades there were actually removed from another building on campus that was being renovated at the time. They were originally sunshades. So we looked to reuse those materials in this project as part of a waste positive strategy for the whole project. Some other ideas that we used were that were part of a wider waste management and design plan was using all the offcuts that were created from joinery, cutting them up into 100 mil strips and making a kind of feature out of that, and really celebrating that story behind the design approach. And the fourth was rather simple really, but again, just looking for products that have a really high recycled content. In this project, there was rubber flooring, and the acoustic material was all 100% recycled from recycled material and recyclable. And something that was also important to consider in that was the end of life. So make sure you don't contaminate those materials when you're installing them. So we use mechanical fixings rather than glues to do that, to make sure they could be recycled at the end of their life. So this project started in 2007. It's on site now. But what I've been thinking about is what would we do differently now? Things are changing really, really quickly. And right now, we now have the ability to assess and measure in more detail the carbon impact of design decisions and options throughout the design. So we can do more than follow principles. We can actually start to measure those and manage carbon like we would a financial budget, a carbon budget. And that idea of kind of integrated carbon management is growing, and hope to see a lot more of it in projects so that we can have those discussions around value and how do we spend money, how do we spend carbon to get the best outcome for our clients. So guided by the Living Building Challenge, this project team embraced an integrated design and co-design process, which enabled a really climatic and culturally responsive design, which also built a real sense of identity that was connected with low carbon. It's also passively designed. But I think we're only really just starting to grasp the potential of that approach and what it could mean to really build a new kind of architecture and built environment in the future. So I'm really excited to think about what that future might look like for Auckland, given more of that approach. And Arch, I'll hand back to you.
Awesome. Thanks very much both for those thoughts and provocations and case studies and info. So it's been really fascinating listening. I've seen there's quite a few comments and things coming through in the chat, and there's a couple of questions in there that we'll come to really shortly. So please, now's the time. If you've got any other questions you'd like to ask, please drop them in there. So it's fascinating hearing these really simple 6 kind of action points coming through. And I think those the really big takeaways that anyone who's worked through a design process will relate to is the need to act early and undertake a holistic process. So that impact curve and being able to influence those things really early on. Also that this is a fundamentally new way of designing, not following our current process and just selecting different materials. The entire process is different. And I know from our experiences, good lead consultants, good architects are good collaborators, and those best outcomes come when you really embrace the inputs of those other consultants really early on, when it's easy to pull those levers really easily. And also just loved those comments, Fiona, on the most efficient and advantageous use of things, the simplicity of just selecting mechanical fixings instead of adhesives, really easy stuff to put in, really basic stuff around orientation and window placement. You're paying for one window, put it in the optimal position and work with the team to help you make that decision. But also just the idea that these really small initiatives add up. There are the tiniest steps all contribute to this. And I think, we were talking before starting, we're talking about progress, not perfection, which I think is a really fantastic way. And I wonder if it'd be good to reflect back to both of you. Probably my first question before we go to the Q&A is some thoughts for clients or projects or design teams who are contemplating how they can start on that journey, may not for good reason be able or ready to go all the way to net zero. Oh, excuse me, again, with the cat. What would your advice be for those incremental and smaller steps that they may be able to undertake?
Yeah, sure. I'll talk to that first. And I think it ties one of the questions that I've already seen come in was related to cost of and potentially a big cost premium for going all the way to something like Passive House. And I think the point like you've already made is small steps do make a difference. If not everyone will be able to go from 0 to 100 overnight, but doesn't mean you can't do anything. And then the other point again is not everything that has to cost money. A window on one side costs the same as a window on the other side, but it could have a significant impact on the energy balance of the building. And the other one is things like concrete, for example. Not every building is going to be fully timbered tomorrow. Concrete does have advantages in some situations, and we're not going to get rid of it completely. But it's about using, if you do have to use it, let's use it efficiently and maximize its benefits by, for example, exposing it and taking advantage of the thermal mass.
And yeah, support those comments. And I think that for me, the main thing is about being really clear in what your priorities are. No project can do everything. So figuring out what's of real value to the client and delivering on those first and prioritizing those, and not trying to do everything, but doing one thing well is a good way to kind of focus energy and finances into getting something that's really beneficial.
Yeah, that's great. I wonder if we've got a few Pātai questions coming through now, and there's a couple here. Obviously, really obvious, really valid question is around cost. So Umir's asked, what's a typical cost comparison per square metre for timber versus concrete? And Lydia asked, which you talked to a little bit, Joe, about whether or not the perceived premiums around something like Passive House are an impediment. I know from my own experience, and noting, of course, we don't give cost advice, but on say a 10,000 square metre project we're doing for a public tenant client, that is between 5 and 10% additional compared to steel. I don't know the comparison to concrete, but I think one of the things that as designers and leads on projects we do is we do have that sales role, and actually the ability to talk about the value that offsets that cost. And I know that in this example, considering a timber structure, timber framed building, that's actually able to be passed on in reduced tenant fit out costs, because the actual aesthetics of the building are already in place and there's less of a need to finish them. There's a strong brand value that we increasingly see tenants recognising in rentals. And it's an interesting time now, before this becomes the norm, that these are seen as leadership occupancies, and there's a value attached to that uplifts the brands of those tenants that are pushing that. And I think there's also well-being and productivity benefits, which we didn't specifically talk to. It might be great to hear you talk about that. I know in our own building in Mason Brothers in Auckland, there's been continual monitoring of, sick days, productivity, health, just general, the well-being and enjoyment of team members who work in that space, which are all the return on what no one would deny is some element of premium. It'd be great to hear from Fee and Joe further on that in response to that question.
Yeah, I've kind of got a two-part response. The first is around, I guess, just the direct cost kind of comparisons of timber versus concrete or steel construction. Naylor Love did some great research, I think it was earlier this year, that looked at the carbon benefits of different systems and also took cost into consideration. And what they found was that a hybrid system, so using timber for your primary elements and steel or concrete for bracing, delivered 90% of the carbon, lower carbon benefits, and was a more comparable cost. So I think if cost is a factor, and it always is, start looking at hybrid solutions. And I think the second part to my answer was about those wellbeing co-benefits, and using Mason Bros as an example of a really energy efficient building that delivers a really good internal climate. There's a 25% reduction in sick days were found in post-occupancy research, along with an 8.5% increase in personally reported productivity. And I can thinking more broadly, the building didn't have any car parking, and that was part of a low carbon strategy. And that has led to a 130% increase in people cycling, which is starting to think about those real co-benefits of low carbon design and wellbeing at a city scale. And yeah, we haven't touched a lot on wellbeing today, but yeah, that's a whole fascinating topic, but they really do go hand in hand, wellbeing and low carbon buildings.
Yeah, I'll just add to that. The word that you mentioned, Arch, was perception. I think we have the perception that, okay, you might need an R6 roof on your building, which automatically comes with a huge cost, and might therefore be a hurdle. But as my example showed, that might not necessarily be the case. You don't know that you need to that much insulation. So it's about overcoming that perception. And I guess the other part is considering scale, so that's my biggest issue with Passive House, that it actually rewards size, because it's based on a per square meter energy rate. So building a larger building is actually easier to achieve those targets than a smaller building. An example there is, I think that currently the largest Passive House building in New Zealand is a 600 square meter single family house. And I mean, congratulations for the design team that worked on that, but I'd still argue that there's no such thing as a 600 square meter single family house that's sustainable. So it's about, maybe there's a bit of an increase in cost, but maybe you can overcome that by decreasing the scale of your project by making things more efficient.
And we haven't even talked about form factor and the influence that has just on overall efficiency, and that's a whole topic in itself. There's stuff flooding through on the chat and the Q&A, which is fantastic. So I'd like to roll through these. There's a really good one from Ethan, which I think anyone who's coming into practice, or even those who are now starting to become more familiar with these projects, they're asking. Ethan asks, can you speak to how prioritization of the client's desired sustainability outcomes can best be managed? Now, if I understand this correctly, this is, that early stage when you are looking to set the project vision and make those big moves. There's a lot of information for clients. There's a lot of variability in there, and the team's experience in how to navigate that process. Some insights on how that's broken down and the right early choices are presented and made early on would be awesome.
I think for me, I think it's about getting that story straight. It's about being able to talk about sustainability in a really simple way that everyone understands what the priorities are. And the way I like to go about getting there is making sure that you have a workshop to start with, and actually put the time aside to ask those questions, the really important questions that will lead you to those mission statements and those answers. The next step is around being clear on what the focus area needs to be for the design team to achieve those outcomes, and setting measurable targets to achieve those, and looking at what kind of strategies or approaches might support that. And then underneath that, then making sure there is still a broad kind of baseline of holistic sustainability that considers social, environmental, and economic outcomes. And then I think going in throughout the design processing and managing it, I think taking a similar approach that we do to cost. So making sure that the outcomes are assessed at each design phase and checked in on, and those discussions are being had about what sustainable value the design is providing, enables that to be managed in a way that is more kind of upfront. It's a lot easier to do it that way than, I guess, having a list of features and kind of arguing for them in a value engineering process, which is, I think, something we'll all be pretty familiar with from previous experience.
Yeah, I'll just add to the importance of measurable goals, I think, is really key. One of the questions I get all the time is, should I certify my building using Green Star or Passive House or whatever other criteria there is? And that's not necessary. You can build a sustainable building without having a plaque on the wall, right? But the importance is, again, measurable goals. If you just say, yeah, I'm going to be sustainable, but without having anything to keep you accountable to those, ultimately a lot of the things end up getting lost along the way, whether it be for cost or other challenges. So it doesn't have to be a accredited third-party recognized standard. You can make your own list, but it's important to stick to those.
And I think I'll add to that, a lot of the discussions that we're seeing recently around what are the drivers for sustainability for our clients, a lot of that is becoming more driven by governance of those organizations or individuals. And things like sustainability linked lending can have certain outcomes that are a requirement of a built investment. And so understanding what the kind of outcomes are from a governance level as well, not just qualitative outcomes, but quantitative, measurable outcomes, really leads you to then need to define measurable targets and manage those to deliver in a way that is data and scientifically kind of proven to deliver on the outcomes that finance levers have started to define, which I think is really a really good thing for the building industry, because financial levers are really powerful.
Thanks both. It's really interesting too when we stray into measurement systems and rating systems and all of those sort of things. One thing I've certainly seen over the last few years is more and more desire to see those measured outcomes somehow displayed in the building or the site, so that the occupiers or the residents really feel that strong connection with the role that their home or their workplace is playing. How much water did you harvest today? How much water did you filter? How much power did you generate? I want to go to a question. We've got similar questions here from Peter and Sarah, and be really good to hear from you on this, on the strategy of reuse of buildings rather than demolish. What are the benefits? How do you compare those? And I think, again, it's interesting to see the shift in the Pritzker Prize, the so-called Architecture Nobel Prize awarded this year to the French couple, whose work is primarily about building use, and the idea that the most sustainable building is the building you don't build. It'd be great to hear from you on any thoughts and insights on what the use case is, how to swivel that use case for retention. And in New Zealand, as Sarah's question noted, we've got so many buildings coming up for that refresh cycle and the opportunity there. Who wants to go first?
I will. I think our Mason Bros building in Auckland is a really interesting example of this. So this was early 1900s, not 60s or 70s. And it was a engineering kind of manufacturing building. If you aren't familiar with it, a big kind of brick warehouse, essentially. And this building and the primary structure was reused as part of the new development. And through life cycle analysis, this building was shown to have about half the carbon emissions of a comparable building. But a lot of that was actually attributed to the energy efficiency. So there were no barriers in achieving a really energy efficient building using an older structure, which is really good to see demonstrated. But something else to keep in mind is that I think we would automatically expect a massive reduction in embodied carbon from reusing a lot of material, but it really does depend on kind of that use. So if you're transforming or just renovating a building for the same use and kind of bringing it up to standard, that's fantastic, and that seems like a no-brainer. We do just need to be careful when we are kind of changing the use of buildings that we're aware that kind of an entirely different use might require an entirely different structure. And we unfortunately didn't see the amount of embodied carbon reductions we might have expected because we needed to introduce new structure to put internal floors in and things, for example. So I think I guess the answer of kind of whether it's appropriate really comes down to how you're going to use the building, and I think measuring it is really key to kind of understanding if it's a good idea or not. But yeah, I think that was a really interesting insight to be able to kind of reflect on that project through measuring it and what the successes were and what we might think differently about in future projects.
The only thing I'll add to that is, I guess, the importance of designing flexible buildings from the beginning. And durable, especially, right? So making sure that you don't, if there is an expected change in use, how easy is it to convert that building rather than having to tear it all down and starting over? And in terms of materials, making sure you don't use things that are going to have to be replaced every 2 or 5 years, right? That are going to last.
And I'll maybe just add another comment. I think all of these decisions need to be considered, can take a step back and look at the holistic nature of them. A lot of our heritage buildings or buildings from the 60s and 70s have a lot of cultural value, and they build a really exciting urban fabric, and that also has value. So I think we need to kind of make sure that we do take a holistic view when we're looking at assessing things through a carbon lens.
Oh, thank you both. There's a couple of questions here which naturally stray into the how. What is enough and what is fast enough? Got an anonymous question that asks, do we need to see the government push reducing embodied carbon and promoting low carbon buildings more to get on track to meet the agreement? And another question about really how to bring about more adoption of green building as the norm. Would a carbon budget, carbon cost fast track wider adoption? And I wonder if you'd be prepared to venture an answer on what role really legislation and getting us to where we need to be and in what time.
I don't know if it was just me, but I think you slightly cut out the arch, but I think I'm really excited to see the climate change framework being proposed by MB and starting to see those targets that people can start to think about in the future, the initial and intermediate caps, and finally where we want to head, which is kind of aligned with that passive house level of energy efficiency. I think that gives a really clear indication to the market about where we need to head, and people can start to upskill. I think I wouldn't underestimate the amount of change that is required in the ecosystem that delivers the built environment. It is vast, and every part of it needs to come along on that journey. So I think like a big step change can cause kind of economic shock and cultural shock, and kind of build a bit of fear, I guess. But having those signals about where we're heading, we really need those so that we can kind of all upskill and get ready to deliver like we kind of have never before.
Yeah, I definitely think there's a role for legislation to play here. I think in terms of owner-operated buildings, we're already seeing a shift because people are thinking about more of a life cycle cost, and they are recognizing that by spending a bit more upfront, they're going to save money in the long term. Unfortunately, some of those incentives don't apply to developers because they are incentivized to build as fast and as cheap as possible. But I think what I mentioned early on is that it doesn't necessarily just have to be strict requirements. You can have the same impact through incentives. For example, the one I'm used to from Vancouver is that by going above and beyond code and increasing energy efficiency, maybe a building is awarded extra density, for example, which then directly translates into profit for a developer, making it a great incentive.
Yeah, I think we would have liked to have seen those kind of ideas of incentives applied to the recent kind of housing densification announcements with resource consent, because those sorts of incentives do really shift the market. And yeah, I think there's other incentives as well that are financial levers that we also need to think about, and I think really advocate for and promote. They're kind of my preference rather than a carbon tax, which I'm sure is inevitable. But thinking about how we can have development incentives, funding incentives, so looking at different financial funding models like the sustainability linked lending or green bonds, and also the discussions around TCFD, making sure we're aware of kind of the climate risk that we put into projects if we don't consider sustainability, and how does that affect kind of an investment going forward, and kind of painting a financial picture that's not just about capital cost, can really kind of start to shift that cost discussion.
Awesome, thank you both. we are pushing right up against 10 o'clock, and we've got a really fantastic attendance today. And I'm mindful that many of you may be wanting to push on to your 10 o'clocks for tea or meetings or however else your day's panned out. So we'll wrap up there. Apologies to everyone whose questions we couldn't get to. This fantastic chat and shows the level of interest. Really hope that today has been useful and interesting, and really want to thank our two speakers, Fiona and Joe. Thank you so much for the time put into preparing to talk to us and your insights today and answering all of the questions. And thank you very much to everyone for attending today as part of Auckland Climate Festival. Thank you very much. We will wrap up there and let you move on to your next one. Thanks very much, both.
Cool.
Thank you.
Thanks, everyone. See ya.